Hello friends, today we are going to discuss an interesting question which is common in competitive exams like SSC JE, PSC and GATE. So here is the question. Try to pause the video and read it. So the question is, find the equivalent resistance across the diagonal corners of cube with each resistance being R. So there are total of 12 resistors of resistance R with each resistor representing the edge of the cube. As we know, a cube has total of 12 edges, so there are total of 12 resistors of resistance R. We need to find the equivalent resistance across any two diagonal corners of the cube. For that, assume the diagonal corners as A and B. For the diagonal corner A, the opposite diagonal corner is B. We need to find the equivalent resistance along A and B. There are several methods to find the equivalent resistance. Out of that, we are going to select the most easy, which is the VI method. For that, we need to consider a voltage source of voltage V delivering a current I. We need to form an equation involving V, I and the resistance R, so that after solving the equation, we can get the equivalent resistance along A and B. I know this might be confusing for you at start, but I assure you, after watching the full video, you will learn the concept of VI method. As the current is delivered by the voltage source, it reaches the junction here. As the current I reaches here, it can go through these three paths. Assume that these three paths has equal resistance. Please note the point, I told you only assume. We can't say for sure that these three paths has equal resistance. We can take our assumption as correct. If the total current returning here is I, then only we can take our assumption as correct. So for now, assume these three paths as equal resistance, so that the current I can divide equally along these three paths as I by 3, I by 3 and I by 3. These I by 3 currents travels and reaches these three junctions. As this I by 3 current reaches this junction, it can go through these two paths. Assume that these two paths also has equal resistance. So the I by 3 current can equally divide along these two paths as I by 6 and I by 6. Similarly, this I by 3 current also equally divide along these two paths as I by 6 and I by 6. Also this I by 3 current as I by 6 and I by 6. These two I by 6 current reaches this junction and add to this path as I by 6 plus I by 6, which is total equal to I by 3 along this path. Similarly, these I by 6 current along this path and these I by 6 current along this path can reach this junction and add as I by 3 here. Also these I by 6 current along this path and these I by 6 current add as I by 3 along this path. So there are total 3 I by 3 current reaching this junction. So these 3 I by 3 current are totally as total current I. So our assumption is correct. A total of I current enters this point and a total of I current leaves this point. So we can take our assumption as correct. So now we just have to find a loop where we can solve this circuit very easily. Pause the video and try to find which loop is best suited for our question. Yes, you guessed it right. This is the loop. We need to solve this loop by using Kirchhoff voltage law to get the equivalent resistance along A and B. For that, we need to focus only on this loop. For the time being, let's just neglect this circuit. Now we need to focus only on the partial circuit. Please note that this is not a complete circuit, this is only a partial circuit. The remaining resistance are connected here. For the easy solution only, we are considering this partial circuit. We need to write the KVL equation of this loop so that we can get the equivalent resistance along AB. As we know, Kirchhoff voltage law defines that the algebraic sum of all the voltages inside a loop is 0. It can also be termed as the voltage delivered is equal to the voltage dissipated. So the voltage delivered here is the voltage source of voltage V, and the voltage dissipated can be taken as the product of IR. So here the current passing through this resistance R is I by 3. So it is taken as V is equal to R into I by 3. The current passing through these resistance is I by 6. So it can be taken as R into I by 6. Similarly, the current passing through this resistance R is I by 3. So the voltage drop across these resistance can be taken as R into I by 3. We need to solve this equation to get the equivalent resistance along AB. It can be solved as V is equal to 5 by 6 into IR. We need to take the V by I ratio to get the equivalent resistance along AB. So that we get the V by I ratio as 5 by 6 R. So the equivalent resistance along AB is 5 by 6 R ohm. So we now got the answer as 5 by 6 R ohm. If you like the video, please subscribe to my channel for more such videos.